If they still don't get it, they're just not ready for it. It's kind of like, if you try to use a Reck and Rec and they want to count the beads, each and every one of them, they haven't done near enough Kathy Richardson stuff. They don't know how to decompose 10 or how to decompose 5. Kindergartners have to really learn how to decompose 5. That seems so easy to us, and if you walk into a kindergarten class in September or October, lots of kids will not know how to decompose 5. If I have 2 cookies and mom says I can have 5, how many more do I get? Is a hard problem that they actually have to work out with manipulatives and language. Okay? And that's why you have a 5 frame. Because a 5 frame is all they really need at that point. And then you go up, you graduate to a 10 frame. You don't start there. Okay. So, now that we've talked about that, I want you each at your tables to come up with a division problem which will have a quotient of 203 and a remainder of 11. There are an infinite number of problems that fit that category. You need to come up with just one. Come up with a division problem where I know the dividend, the divisor, the remainder, and the quotient, but I'm specifying this has to be so. Go ahead and do that.
We could just do times 2.
Times 2.
So 606 plus 11. Yeah, that'll do it.
406.
Is this class over in 15 minutes? I must have been off target a lot.
You were playing a lot today.
I was bad.
I'm so sorry.
What's 666? What? I can't post 666.
It's a good thing I already made the decision for Thursday instead of Tuesday. You would have been so at that special
So,
creek.
so we just need something, anything times this plus 11. Is that what?
Plus the
You
remainder.
get 617.
Wait, something times 203.
Okay.
Plus 11.
I can't,
11.
basically, can't do anything.
Alrighty, Carrie, your name got drawn.
All I've got written down is 203 remainder.
Okay, so talk with me about the relationship between the divisor, the quotient, the dividend, and the remainder.
Okay, well, if you take
Just a second, Tim. Go ahead.
quotient
Yep,
times your divisor
divisor.
plus your remainder,
That would be your
that'll give you that.
bingo. What number do you want here as your divisor?
Could you just try something?
Yeah,
Okay,
absolutely.
let's try 8.
8. Okay, you like to multiply by 8?
Not really.
Okay, it's 1624. Can I do it for you?
Yeah.
Okay. 1624 plus 11? 1635, right? Okay. So here, I gotta put these in the right places. This is the problem, right? How many people agree that this will work as the dividend? Thumbs up. How many people are not sure? How many people disagree? Okay, so we have a few agreeers and a few disagreeers. So right now, do the math, divide 1635 by 8, and we're gonna find out if it works. Huh, didn't work. Why not, Carrie? It was a beautiful idea. It didn't work. Why not? How far away are we, Carrie? 1 away and a remainder of 3 instead of 11. Why? You did everything right except you didn't have one relationship in mind when you did it.
I
What?
wasn't looking at the 3 times 8.
Well-
Everything worked until you got to the end.
Yeah. So why didn't it work at the end? How many 8s are there in 11? Remainder? Didn't you just say that this was off by 1 with a remainder of 3? Huh. What's unusual about this problem, Carrie?
The remainder is bigger than
So what's that mean? I could have gotten one more group with 3 left over. So what has to be so? Every single division problem in the whole world ever, divisor has to be larger than the remainder?
Yeah.
It does. Okay. The remainder has to be smaller than the divisor, or the divisor has to be larger than the remainder. I always say it the other way. I stop to think of the way you're saying it. It'll happen to you in your class all the time. Okay. Now, all right. I'm hurrying. So now that you know how to find dividends, spend a moment and find at each table half of you do problem number 1 and half of you do problem 2. I specified the divisor, I specified the quotient, I specified the remainder. It's your job to find the dividend. No calculators, please.
Okay, I'll do number 2.
I'll do it. I don't know. What do I do? I'm very confused.
With Bob's Beetle Boxing Business, do you remember we were subtracting thousands of beetles at a time? Tens of thousands of beetles as our divisor. Well, I've made this one a lot simpler. I've actually chosen this problem over here, because I found it already, 31,261. And this one was 23,749. Anybody get different? Okay, those have been verified. Those two you need to write down in your notes. We're going to come back to those numbers a lot.
What number?
31,261 and 23,749. Those are the dividends. Okay. So Sam? Is this going to be harder or easier with machine 1 than those huge numbers that we were subtracting before?
That is gonna be definitely hard.
Why is this definitely harder? If I gave you this problem and said, if you guys get this done in the next 15 minutes, we get extra recess. A lot of kids are going to say, ooh, let's get going on this. And what's going to happen? After they fill up page 1, after they fill up page 2, they're starting to look at me like, Dr. Baines, you tricked us. I did. How many subtractions will this take with machine 1? If I subtract 24 and 24 and 24 and 24 and 24 and 24, it will take,
13,2.
it'll take 1,302 subtractions. With machine 1, the quotient is the number of subtractions, because all we ever divide is by subtracting, and all we ever do is subtract the divisor over and over and over again. It's called straight repeated subtractions of the divisor. Machine 1, the number of subtractions is the quotient. Is this a friendly problem with machine 1? No. Oh, I forgot to tell you, those lovely people over at Bob's Beetle Boxing Business, they sent us a new machine. Instead of using machine 1, which will take all afternoon, we can use machine 2. Machine 2 has special buttons on it, a 10,000 button, a 1,000 button, a 100 button, a 10 button, and a 1 button. What is true about all of the buttons on machine 2? Savannah.
They
Say it again?
Oh, well, okay, on our paper, it's the opposite way, so it's 1 to 2.
It doesn't matter. I do it this way now.
Okay.
I did that older. This is updated.
Well, then now they're decreasing by times.
Okay, but if we start at the bottom, they are place values or powers of 10. Okay? So 1, 10, 100,000, 10 to the 0, 10 to the first, 10 squared, or place value names. Our buttons are place value names, okay? So Savannah, what, if I told you with machine 2, instead of subtracting 24 each time, I want to go for the largest, which is why I put it at the top, the largest multiple of 10 times 24. So this would mean subtracting 10,000 groups of 24. Do we have enough beetles in the beetle bin to hit the 10,000 button? Okay, because what's 10,000 times 24?
24,000.
What's 1,000 times 24?
2,400.
What's 100 times 24?
240.
What's 10 times 24?
Oh wait, 240. Okay, I think I got.
Good, you
So-
did. And so you stayed true, which is a fabulous thing, and people do that all the time. I was throwing a continuous barrage at your knee, and they kept hitting you, okay? And for that I apologize. And what you did is exactly what you're supposed to do, which is notice that it's always divide by 10, okay? But you did your initial multiplication wrong. What is 10,000 times 24?
240.
240,000. I don't have enough beetles. Can I hit the 1,000 button?
Yes.
What is 1,024s?
24,000.
24,000. So I'm going to type in 24,000 here. How many did I hit? I hit the 1,000 button. So I'm going to write that out here, okay? Now I have 7,261 beetles left. Can I hit the 1,000 button again?
No.
No. Some kids will say yes because they're comparing 1,000 to 7,000. But it's 1,000 groups of 24. It's always the button times the divisor number of beetles, okay? So I can't hit the 1,000 button again. Can I hit the 100 button?
Yes.
And 100 times 24 is?
2,400.
2,400. When I subtract, I get 4861. Can I hit the 100 button again?
Yes.
Another 100 is 2,400. Subtract and I get 2,461. Can I hit the 100 button again?
Yes.
61. Can I hit the 100 button again?
No.
Can I hit the 10 button?
Yes.
Because 10 groups of 24 is,
Oh wait, no, you can't.
I cannot. Can I hit the 1 button?
Yes.
Because one group of 24 is
24.
24. I subtract, I get 37. Can I hit the 1 button again?
One more time.
One more time. Now, I set up this problem so I knew what the answer was, I knew what the remainder was, and I knew what the divisor was. The only thing I had you calculate was this. How many subtractions were there? 6. I knew that ahead of time. How?
I think, well, it has something to do with the place value.
It
I think
sure
that-
does,
but
yeah.
I only guess there's 5 digits in 31,200.
Okay, and it's not related to that at all.
Okay.
But thank you, that's a lovely guess. That's better than a whole lot of them you could have come up with. Okay? So, how many times did I hit the 1,000 button?
1 time.
1 time. How many times did I hit the 100 button?
Oh, 3 times.
3 times. How many times did I hit the 10 button?
2 times.
That's the one. How many times did I hit the 10 button?
Oh, 1 time. No,
Where-
you didn't hit it any time.
0 times. How many times did I hit the 1 button?
2 times.
2 times. How many buttons did I hit altogether?
6 times.
6 buttons. How can you find 6 buttons in this answer? How is 1,302 related to 6 times I subtracted, 6 times I hit a button?
I really don't know.
Okay, how many times did I hit the 1,000 button?
1 time.
And the 100 button?
3 times.
That's 4 so far, right? And the 10 button? I didn't. And then 2 more? That's 6, right?
Right.
1 plus 3
Oh,
plus 0 plus 2 tells how many subtractions, how many times I'm going to hit a power of 10 button. Okay, here's the deal. Machine 1 helps you figure out the relationship between division and subtraction. Machine 2 helps you figure out the relationship between division and place value, okay?